Okay, guys, our last video is going to be on solving systems of equations that don't give you a single answer like the ones that we've looked at so far. So we've got an inconsistent system, which is one that will give us no solution. And I also have a dependent system, which will be infinitely many. I'm going to work this first one with substitution and the second one with solving by elimination by addition so that you can see what happens to the equation in both methods, okay? What you're going to notice with either method is that the x's and y's both disappear. They both add out to 0, and we'll be left with two constants, one on either side of the equal sign. If those two constants are equal, then it's a dependent system, and we have infinitely many solutions. If the two constants are not equal, it is inconsistent, and we will have no solution. So if we work this one by substitution, if you notice, we've already got one equation that's solved for one variable. Okay, so I'm going to use that to my advantage, and I'm going to take the 9 minus 2y and plug that into the other equation for x. That's our second step, since we don't have to really do the first step here. That's going to give me 9 minus 2y in for x, plus 2y is equal to 13. This one falls apart pretty quickly. We eliminate x naturally by doing the substitution, but then when we go to combine our y terms, they are eliminated also. They will add to 0, and then all that's left behind is 9 equals 13. Well, that's not true, right? It doesn't matter what two numbers you get here. If you work the problem a little differently, you might get two different numbers. But the point is, they'll always be different on both sides of the equal sign. So you're always going to get a false answer from this particular system. And that just simply means that this system is a system of parallel lines and that there is no solution. So on your homework, you should have a radial button there to click when you get to the ones that are no solution. All right, let's take a look at our dependent system. We'll solve this one using elimination by addition, just to give you a little bit different feel for it. The first thing that you're going to do, and I don't really even need that line, we need to get one of our variables positioned where we can get rid of it. It doesn't matter which variable you pick. I'm going to choose the x's. So I need to figure out what to multiply one or both equations by so that they have the same number but opposite signs. This is a little easier than the one we did in the previous video because we can just multiply one equation by a value here instead of two. And we do have some common factors that we can play around with. If I want to get rid of x, I'm going to need the coefficient on the first equation's x to be negative 3. So I just multiply that equation by negative 3. That's going to give me exactly what I need. Then I've got 3x plus 9y is equal to 6. And what you'll notice on a dependent system is when you go to finish the problem, if you're doing elimination by addition, everything adds to 0. The x's are going to add to 0, the y's are going to add to 0, and the constants are going to add to 0. So we wind up getting 0 equals 0, which is true. And that means that this is a dependent system with infinitely many solutions, or an infinite number of solutions, I think is what your homework mainly says for that. You just click that radial button on that one, okay? And you can work these by substitution if you'd prefer. We could have done this one pretty easily by substitution, just right here solve that for x, and then we would have had something that we could have substituted in here for x. You would have seen something very similar to the previous problem happen there. We would have lost our y values, or y terms, because that's what would be left. And we most likely would have gotten 6 equals 6 if we have gone that direction. So you can try that. Try doing this one by substitution. Then go back and try doing the previous one by elimination by addition. You should get the same thing as far as you should get false on that one, true on this one. Your numbers won't be the same necessarily. By substitution, I bet you're going to get 6 equals 6. And on the previous one, if you do elimination by addition, I think I remember it coming out to be 0 equals 4. So anyway, that's it.